Well, with that stunning introduction, this is probably the best or worst version of Sleigh Ride ever played. That one's called Sleigh Rough. And those people, I believe, are still for hire at any time of the year. They seem to have a lot of open dates in their calendar for some reason. But my name is Martin Hubel. I'd like to welcome you all to the show number Z122. And I think I've hosted at least well over 100 of those shows. It's great to be here again. And our topic today is Data Gate, current and consistent DB2 for ZOS data on any cloud. And my special guest today is Sowmya Kameswaran. Hope that's close. How are you doing, Sowmya?
Thank you, Martin. I'm doing well, and you did get that right.
Oh, thank you. We do our best. And, sometimes our best is better than other days. So let me just go through the quick introduction here and do our normal things that we do. As always, our social media page, the main things to do is to follow hashtag DB2Night on Twitter. You'll get updates on shows, and I'll announce when replays are available on things like YouTube. And YouTube is the latest service we're using for replays. It works really well. We also have our LinkedIn group, which isn't all that busy, but we like to have it there, and we do check and make sure that people are putting in suggestions that we get them. Here's our disclaimers, as always. Everything's copyrighted by the respective people. We respect the copyrights. We are recording, and as such, we do make replays available. And it's all copyright 2021 by DBI, our founding sponsor of the DB2Night show. And here are our quick announcements of upcoming shows. We've got the DB2 Access Plan Troubleshooting Handbook by John Hornibrook of the IBM Toronto Lab. He is the man. He's been doing that job for a very long time, and he's a good guy and a good friend of me personally and of the DB2Night show. And on February the 12th, I believe that's going to be something called Watson Query, but we're still calling it New Stuff in Writing. And Piotr Merzejewski of the IBM Canada Lab will be presenting that. I call it the IBM Toronto Lab, and it's really in my hometown of Markham, Ontario, where that lab is. And Peter will be here in February to do that. Next month, we have another thing on DB2 on Z. Patrick Bossman of the SVL Lab. I know he works from Florida, but he's going to be presenting on Data Studio and Data Server Manager, the replacement for that. So that's a show that you won't want to miss. As always, our founding sponsor has a demo available if you're interested in tuning DB2 LUW. And that information is available on the DBI website. They have a demo you can watch. If you do, you get a gift card. Our winner from last month's show attendees is Kevin Nadeau of Cigna, and he's getting an Amazon gift certificate. That's really nice. And our sponsors, as always, is DBI, the people that started the show, and yours truly, who is now the host of both the Z and the LUW shows, Martin Hubel Consulting. And now we're into our polls. I'm moving along quickly because I want to make sure that we give Sowmya as much time as possible. All right. And our first poll is a typical one we always ask is, what's the highest version of DB2Z that you have running? And we'll get some votes in on this. This is helpful to know how our community is doing. Good to see that we've got a lot of people. Oops, everybody's voted, so let's close that off and share that. And yay, I think for the very first time we have an audience which is on V12 only. No version 11 left, or they might have it left, but we've all moved to V12. That's good news. We'll hide that and move on to our next question, which is, how about this, which version of DB2 LUW, if you have it? Again, things are looking pretty new here. That's great news. We'll close that off and share that. And we have mostly DB2 11.5, a little bit of 11.1. That's good news again. Good to know. I'll hide that and move on and share the next one, which is, when do you plan to move to DB2V next? Now, this is, I believe, what you'd call not a closely guarded secret anymore, because they've, in many places, they're now calling it DB213. But the question is how soon do you think you'll be moving to that? And as it sits right now, it's be hard to do in the next 6 months per se, but might be possible next year or other things of that nature. We're up to 80% voted, so we'll close that off and share the result. And people are really saying they're looking more towards a year from now or so, and that's just fine. And the last question we have relates to the topic. In terms of working with the cloud, do you have a roadmap for getting onto the cloud? There's part of me that looks at the cloud and says it's a great thing, and other people say, well, you know, I'm going to hold off on that for a while, but we'll share the result there, and we see that 20% say yes, another 20% each on working on it, and the others are not sure. So that takes us to the end of our polls, but that's good information. Thanks for all for participating. So let's move along and turn things over. You should be seeing my screen again, and as such, I'm going to, at this point, we'll turn it over to Sowmya, and let me come up here and make you the presenter. You should have a note saying that to accept to become the presenter.
Yes, give me just a moment, Martin.
No worries. And as you get ready to present,
so Mark, I may have to quit and reopen because it just won't let me screen share without it because it's a new app. So I'll be back in just a second.
Sure, no problem. Oh, in the meantime, we'll listen to more of this wonderful tune here. These people have practiced all day to get this song right.
Hey Martin, I'm back. Can you make me presenter again?
Sure. Interesting. Oh, it says you are the presenter. I guess I need to make the other one, the other you a presenter. Just a second here.
Oh, possible. I don't know why there are two me's. So, okay.
Sorry, I'm hitting the wrong button here. That's never happened to me before. As if. Let's try this one here. Make presenter. And now you should have the message.
Yes.
And as soon as you click that button, we'll see your screen. Perfect.
Okay, so that's good. Okay.
Perfect. You might want to go in, you're in PowerPoint, you probably need to go into presentation mode.
Yes, I'm going to do that in just a moment.
Sure.
Okay. Looks better?
Looks great. Actually, you're sure. Yes, perfect. Okay, what I'm going to do is mute myself, but I'll turn my mic on and ask any questions that come through. I'll be following that.
Sure. Thank you. Thanks, Martin. Okay, so let's get started. Hey, everyone. I am Sowmya Kameswaran, and I work at the Silicon Valley Lab in San Jose, IBM Silicon Valley Lab in San Jose. I lead the user experience transformation for DB2 for ZOS platform and the ecosystem. And today we're going to talk about, it's an exciting new technology, Data Gate. So what I have planned today is to start with an introduction on Data Gate, and then I'll do a live demo, so all of us can see Data Gate in action. And then we will discuss some of the underlying technologies that enable Data Gate to do what it does. And finally, we'll talk about some performance measurements from the lab, and what's new in this in the Data Gate, the latest releases of Data Gate. Moving on, so Data Gate is a service that is built on top of IBM's Cloud Pak for Data. So it runs on all the platforms that are supported by Cloud Pak, which includes private cloud, Linux on Z on mainframe, Intel-based bare metal, VMware-based systems, AWS, IBM Cloud, and all of that. Data Gate, what it does is makes data from DB2Z consumable for cloud-based applications. So now that I understand that's a very broad and generic statement. So what does that really mean? Most of us know that DB2Z has one of the largest footprints in the enterprise database world. This also means that a majority of the business critical data resides in it. With a spike in the application development these days, there is need for reporting applications that require read-only access to transactional data, as well as analytical applications requiring access to historical data. The need for this data to drive these new and possibly cloud-based applications it doesn't eclipse the need to keep the existing business critical applications on Z, needing timely and reliable access to the data that is on DB2Z. Now, some organizations have built custom extract, transform, and load ETL jobs to make the DB2Z data available anywhere, and on the cloud is one of them. While this approach can work in the short term, there are concerns with security as soon as the data is moved out of the platform. And in addition, there is always concern with increased costs of these solutions on Z, MIPS usage, and in general, expensive maintenance over time, because once something is custom, it means it needs maintenance. So this is one of the areas that Data Gate's core value props is rooted, making it easy for new applications on the cloud to access the data on mainframe from DB2Z without impacting any of the existing operating mainframe applications. And the last part with the part where I said without impacting the existing mainframe applications, I think that's one of the key messages with working with Data Gate. On a high level, this is the application processing flow, how Data Gate processes the data. And so there are, on the left side, you see that the IBM Z box, which has the traditional DB2 ZOS applications, HTAP applications, all of them are running within Z, the mainframe, and any SQL requests are sent to DB2Z. And the way Data Gate fits into the picture is that Data Gate is an external, Data Gate itself is an external component, but it works very closely with DB2Z by synchronizing data using this integrated data synchronization protocol from DB2Z as a source into DB2 on the cloud or on the platform, Cloud Pak platform, as the target. And the Cloud Pak platform, the target on the Cloud Pak platform could be either a DB2 advanced edition, which is best suited for transactional workloads, or a DB2 warehouse, which is best suited for analytical workloads. And any of the newer applications, transactional or analytical, can query data that are running on the cloud, can query data directly from the target DB2 databases. So I'm going to pause right here. I'm going to stop my screen sharing and move to, to demonstrate the product itself in action. And then we will come back again and talk about some of the enabling technologies and how things work. So for those who are familiar with Cloud Pak, I'm sure you've probably seen this in many other demos from other IBMers or site, but this is the landing page, and just to kind of show where Data Gate is located, it is one of the data sources on the platform, and oh, I'm sorry, kindly bear with me. No, I think the system, there is some network lag because I am doing this live. So it is one of the data sources that you will see here. So you see IBM Data Gate right here. And this is, if let me just walk you through how to create a new instance. So I don't have a transactional database provisioned on this instance yet, but I do have one analytical, which is my current instance is already using, so it doesn't show up on the list. But anyway, the first step is to create what kind of database you want to use as the target based on the use case, and it could be transactional or analytical, which is advanced edition or warehouse. And after that, you select the resources that you want to allocate to this database to this data gate instance. The namespace, the storage, the route, and this route is used for communication and communication between data gate and DB2. And once with all, this is all the information that you need to provide. And once this is done, clicking on review and submit would create a data gate instance. Typically takes about 7 to 10 minutes, anywhere around that time range. I do have one provision, so I'm just going to go in there from the instances page. And so you can see here, I do have a DB2 warehouse. This is the data gate that I'm going to use today. And let's go in there. So when the page finishes loading, you will see like a landing page or a dashboard for Data Gate, which shows a few metrics through the place. And for some of you who may be familiar with IDAA, a lot of them are, a lot of the concepts are shared between the way Data Gate works and the way IDAA works. There are differences because Data Gate is, of course, more suited towards this, the cloud use case. IDAA is different, but so here's how the dashboard looks like. You have the name of this Data Gate instance, the target, which in this case is a DB2 warehouse, and if I click on this, I'll be able to see the details and update the access token for internal communications. The source is, this is the DB2Z system that I'm working with, and you can see that the log reader part is how the integrated synchronization is going to start reading data, and we'll talk about these things in more detail when we get back to the presentation. And the TLS certificate is all communication is handled securely. So setting up a certificate is necessary for us to proceed with Data Gate. Yes, so I'm not going to change anything there. So we'll come back to the dashboard. While the panel loads here, I'll talk about these two graphs. So we have the synchronization latency and the synchronization throughput, and which both of them are to indicate how the replication or the synchronization of data from the source to target is going on. The latency shows if there is a lag, and if there is, what is the average time lag. And for the throughput, it says how many rows per second were transferred from the source to the target, or synchronized from the source to the target. I haven't run much because I think, and the system is also quiet because most of them are on vacation. So back to the left panel here is, it says that the Data Gate server is active. That means all the health checks are okay. And this one, the query acceleration part, this is actually a feature. And again, this is, the query acceleration might remind you all of IDA, and I think logically it is the same. This particular capability is in technical preview with Data Gate right now. And yeah, so we are still working through the use cases for query acceleration, and testing and all that is still ongoing. So in this case, I do have this instance provisioned with the ability to support query acceleration. And so here is a quick snapshot of the number of tables loaded, number of queries that have executed against this, accelerated against this Data Gate. And so here I can see the tables that I have loaded. And if I need to add more tables, I can come here, I can select, so let me pick one, sales demo, and it lists all the tables. If I have a huge catalog, to make it easy, you could just type the name of the schema or some characters, and it'll refresh the list below. So in this case, I'm going to proceed with this. I didn't try out adding the schema before, so it might succeed, it might fail, but in either case, we'll be able to see what's going on. So what it does behind the scenes is it adds the tables, and depending on whether so here you can see that if there is an error, it comes back and says that there is an issue with the unique constraint or primary key, and so it couldn't handle this one table. And in any case, it does show up here, does show up as load pending, and I should be able to click on one of the other tables and say load. And if that is able to work, it's going to go into loading, and you'll see, the status refresh. So when adding tables, what happens is depending on whether we chose the enable synchronization and load tables toggle. I probably didn't talk about that when we were at that page. But there is a toggle which gives the user an option to turn on synchronization and load the data for the tables too. And if that is turned on, it's automatically going to attempt to load the table, add the table, turn on synchronization, which is enabling replication or synchronization, and also load the data from the source to the target. And once again, in this case, it did say it looks like tables in that schema have some issue. But anyway, the initial data is loaded, but sync could not be turned on. Let's go on. So I do have 3 other tables loaded here. And if I were to select on one of them, you see that this particular one is enabled for acceleration. It's enabled for sync. It's also initial load is done. And going to the queries tab here, what this does is it lists out if there were any queries that were executed against this Data Gate. So in this case, I did execute a couple of queries last night in prep, and you can see those queries show up here, and I can click on any one of them to look at the full SQL text. Not a very interesting one, but I did the best that I could with the data in that table. So once this is you'll be able to see all the data and associated metrics with it. And if you are interested, there are some more columns that that are there for for you to look into. And the queries section here will also will also refresh to show the latest information as to, in this case, I have 2 successful queries. If you have more executing, it'll show executing, queued, or failed. To jump into the view details, I just want to take you there to show you how this can be monitored, the activities that are ongoing on the a target database can be monitored. There is an inbuilt console, which is called the data management console. And if you click on the warehouse or the OLTP instance, it'll take us to the landing page or the dashboard of that particular database, target database. And from there, you can pretty much manage, monitor, and administer your entire target database. And we will see that there will be a few trending graphs that show up to say, okay, what kind of activity has been going on. And we will be able to kind of map the loads and number of SQL queries that are executing, all those kind of all the good stuff that you can see in this monitor dashboard here. If it was a recording, I could have cut this out, the entire loading, but thanks for bearing with me while this is still happening. So yeah, so here you can see information about the throughput, the system responsiveness, availability, resource usage across CPU, memory, and storage, and also time spent. So in this case, I wasn't doing much, so the graphs are relatively flat here. You can also these are all the other options available. So some more detailed monitoring metrics, and under the data, you have all the objects that you can go look into, tables on the target side, load data from other sources, run SQL. So this is a fully operating DB2 warehouse that is used as the target database with a data gate, but it can also be accessed from externally through using a typical JDBC ODBC connectivity. So, okay, thank you for that. That's not nice, but anyway. So this is data gate. I know it looks fairly simple, but the amount of capabilities that it brings, or what it enables us to do with respect to bringing this Z data into the platform or into the cloud platform, and allowing cloud-based applications to access this data is big. That too, when we know that the data can be trusted and it is secure and all that is taken care of, then that's where DataGate's business value is. So I'm going to go back into presentation mode, and okay. So let's go into some of the components. Take a look at the components here. So we'll start out with everyone's favorite, which is security, right? And this is how we've taken care of security by design. So we all know that security is very important to our users. And as we saw in the demo, all communication with DB2Z goes through secure JDBC and is encrypted using ATTLS using user-provided RSA certificates. Once the data has arrived into DataGate, the Cloud Pak for Data security by design ensures that all the communications, inter-pod communications, is encrypted using CPD's RSA certificates. And sorry, when I say CPD, I meant Cloud Pak for Data. And this also includes any communication between DataGate and the DB2 target on the platform. For the data at rest, all the data that is stored in DB2 is encrypted. I think we all know that, using DB2's native encryption, which is FIPS certified and uses NIST certified algorithms. So the bottom line here is your data is safe. And also, when we say that all the data stored in the DB2 is encrypted, we mean all kinds of data, which includes table spaces, data in the table space, and even transaction logs. So to the next key characteristic, which again, with what is expected these days out of all platforms, most enterprises cannot do with downtime. So high availability is a must. Since Data Gate is built on the Cloud Pak platform, high availability is built in. Kubernetes, which is the enabling technology, takes care of most aspects of high availability by being able to automatically restart failed pods. Storage can be a network storage like NFS or Spectrum Scale, or we could use local storage, host path storage. Using local storage, of course, has certain HA implications, and local storage means storage that is local to the Data Gate services pod. And in case of a disk failure, it can be tolerated up to the RAID RAID's level fault tolerance with no outage. If there is a node failure, it can be addressed by Kubernetes, where it attempts to bring up the pod on a different node. But if the storage was local to the service in the same node, then we cannot do that. So an alternative solution would be to have a second Data Gate instance on the same cluster. In case of container or pod failure, the infrastructure does attempt to restart the pod automatically, and there would be an outage until the pod comes back online. Okay, so this is, I think we are into the, the interesting part of Data Gate, which is the secret sauce, or otherwise called integrated synchronization. From the image here, you can see that there are two major players. There is a log data provider and a log data processor. We'll start talking about the provider first. So the provider component is built into all of DB2Z V12 systems, and there's no additional install required. It follows the same life cycle and support pattern as DB2 engine itself. The provider is custom built with a laser focus on the current use case, which is to move data in the most atomic, consistent, and performant way from DB2 for Z into the target DB2. And since it is custom built for this use case, it does what it is expected to do very well. The design ensures that the CPU usage is minimal and kept in check, and that the throughput is also higher. Plus, it's also nearly fully zip eligible at 96%. The log data processor, on the other hand, is built into DB2 Data Gate and follows the same life cycle as the DB2 Data Gate. So there's no additional install or update steps required to manage and maintain this component at the right levels, since any maintenance to Data Gate would take care of this automatically. Once again, it's purpose-built for data processing, the purpose-built data processing engine. It ensures low latency and high throughput. And multiple organizations have been able to even switch between a bulk and trickle feed mode for data when needed based on the frequency and the volume of data coming in. These two components, the log data provider and the processor, working together ensure that transactional consistency protocol is maintained when queries are running against Data Gate and return the most recently committed data. A little more about the log data provider here. As we already saw, all communication is encrypted using ATTLS, goes through secure DDF. Data Gate frequently polls for data, and whenever there is a new incoming request, an SRB is started. And logs are read from the DB2 recovery log into the memory buffer to avoid any disk IOs, hence making it more performant. The SRB will remain active until replication has stopped or until no log fetch requests arrive within 60 seconds. There is also a DB2 display command, which you can see the bottom right, to check the status of the log reader itself. And the screenshot here, you can see a session ID, there is the current position, and also the status, which in this case says suspended end of stream. This slide is mostly just to highlight the difference between the zip eligibility of the synchronization aspects of integrated synchronization protocol versus CDC, change data capture, which some of you may be familiar with. As you can see, CDC as a technology, the CPU cycles used to replicate data from source to target are not zip eligible. And on the contrary, most of the CPU used in sync, integrated synchronization, is zip eligible, and thus keeps the cost on the mainframe low. Continuing from the previous discussion on the log provider and the log reader, this is how the table loading mechanism, this is the table loading mechanism. Since the integrated synchronization is built and optimized specifically to enable synchronization of data from source DB2Z to target DB2, the load is highly optimized to maximize throughput while keeping the resource usage on ZOS low. For loading partitioned and segmented tables, parallel unload is effected on DB2Z side to maximize the throughput. Segmented tables are unloaded sequentially when loading one at a time. Data transfer to data gate from the source is in internal DB2 for ZOS format. And all the complexity of the conversion to the DB2 target format and insertion into the target DB2 is handled by data gate itself. One of the key things to note here is that with the use of unload and unload with isolation CS, the source tables are fully available and online during synchronization, and they take no outage. They are available for read and write during the entire duration. DataGate also always converts everything into Unicode, since everything on the cloud is Unicode and there is no use for EBCDIC there. Also, this is another part that we saw during the demo, which I think at least the tables that we had in the demo system were not ideal. But there is an option to enable synchronization and load tables when adding tables. And either the user can choose to do that when adding the tables, or they can do that as a follow-on step to load the tables after adding it, and enabling synchronization also after adding. Only the tables that are needed for the cloud-based applications need to be added and synchronized using DataGate, and all the tables that are loaded will be kept in sync when synchronization is enabled. On the target side, new user-defined tables can be created to augment the source data to help us gain new insights. Connection to the target DB can also be done using, we discussed this using a, JDBC, ODBC connection with authorized user ID. And when building applications, this data from the source, which is now on the target, can be combined with data from other sources on the platform to be able to gain useful insights. On a cautionary note, DataGate is built for and can only handle unidirectional transfer between the DB2Z source and the DB2 Linux target, and not vice versa. Although the DB2 Linux on the platform can be accessed directly, it is any changes that are made to the data on the target cannot be synchronized back with the source. So it will not be mirrored back to the source, hence may result in data inconsistency. And also, although allowed, this type of data manipulation on the target is not recommended, as it may cause data instability or issues during synchronization. Moving on, one of the other advantages here is that most of the tasks that are driven through the user interface are handled using stored procedure calls to DB2Z. The interfaces are very similar to IDAA, and this allows for easy automation of stored procedure calls using DB2 native REST wrappers that would be part of the pipeline, and to avoid the need to come to the UI to keep things up manually. Now, this is the next few slides is going to be about a particular capability that we very recently introduced, and it is called as wait for data. So we talked about various technical aspects of which enables performant and secure data movement. And now we are talking about wait for data, which is to enable applications running on the cloud to be able to access current data. For those familiar with IDAA, again, you would have heard of wait for data. And this is a special register that can be used when executing queries. By using wait for data, applications can expect the query executed against the target database to produce the same results as if executing on the source. The screenshot on the right shows a sample execution. The usage syntax is current query wait for data with followed by a value in seconds. The default value is 0, meaning there is no wait, and the query will be executed immediately on the target database. A value of greater than 0 means wait for X seconds for committed changes on the source to be applied to this target by asynchronous replication. If the query is unable to execute successfully for whatever reason, an appropriate error message will be, return code will be shown. Now, one of the best things with this is also that a different value can be set for each query in your application, depending on the needs. So this is how the wait for data works. You see the DB2 on the mainframe, and things continue to execute, insert, update, deletes, OLTP reads, continue to execute on the DB2 data on DB2 source. And from data from the source is transferred to Data Gate through this asynchronous replication integrated synchronization protocol, which is all put into this target database, which could be OLTP or warehouse. When on the right side you will see OLAP and OLTP reads come in, and the first thing that gets checked is most recent committed data required, and you can check that if the wait for data is passed into the from the application. And if it's not required, then it basically just goes directly to the warehouse, and it queries warehouse or OLTP and queries for the data and returns the results. If not, if most committed data is required, then the next check is to check, is the most committed data available? If the answer to that is yes, it goes back to the target, executes, and gives out the results. Otherwise, it initiates an apply, checking the log query position, and goes through this loop, gets the data in there, and then executes the query. Again, this a swim lane representation to make it easy to see how wait for data is in action. Here in this example, there are two threads, thread 1 and 2, and thread 1 and 2 are both updating this table AAA. So transaction 1 does the update and it commits. Transaction 2 does the update and commits. And there is a 3 coming up, update AAA. And that is, we have a query coming at 4 to the data gate instance, which wants to get the data from this table. So what happens is, if a wait for data is included in the query, we wait for transactions 1 and 2, receive and apply the data, and execute the select and return the results. So the results here will include the updates made by 1 and 2, but it will not include the results from 3, any updates from 3, because 3 has not committed yet. Only data that is committed on the source will be will be synchronized with the target. So in order to get the updates from 3, the select query would have to come after this commit. Okay, I know that was a lot. I probably did go through that fast, but if there are any questions, I'd be happy to address them over chat, or even later. I have my email address here. So let's look into the lab performance tests from the lab. I'm not going to go into this, but I do intend to share the slides. So I have two different performance measurements that I have here. So one is the load performance across the board on the platforms that are supported, which is Intel and Linux on Z, and across DB2 Warehouse and DB2 OLTP as targets. We have consistent load rates of 2 terabytes an hour, including the on-the-fly conversion to Unicode. For the synchronization performance, we have here, we split it up into two, for both platforms separately. And you can see for the updates are decomposed into inserts and deletes, and hence have a little lower throughput. But on the maximum, you can see that for inserts, deletes, and on both platforms, we've tested with like 200,000 rows, and we have an average latency of 1.5 seconds. In case it's a transactional or DB2 OLTP, and analytical 1.3 seconds, average latency and max latency of 2.8 for transactional and 1.8 for analytical. I know I'm not going to read through the values here. Once again, I will share the charts so you can take a look at it later. Update performance, yes, it benefits from compression of row store tables. We are nearly coming to an end, and I want to share with you the highlights, Data Gate release highlights from the last 3 releases that we've had in this year. So version 2.0. We did do a technical preview or the query routing support, which I showed in the demo before, to use this Data Gate instance as a query accelerator. And that is in beta, and the purpose is to route analytical queries from DB2 for ZOS to Data Gate to shift the query workload and to save ZOS processing resources. Updating credentials for DB2 for ZOS source database, log reader on the fly, and before this 2.0 release, in order to update credentials, the synchronization flow had to be stopped, updated, and then restarted again. So which would cause an interruption between the synchronization between the databases. 2.0.1 was a fix-only release. For 2.0.2, we enabled data compression, adaptive compression for row store tables by default. And we also added on to the technical preview of the query acceleration use case by adding archiving support, which enables archiving data from source DB2Z to the Data Gate to reclaim disk space on ZOS. The best part is the archived data can still be queried on Data Gate. Version 2.0.3 brought in which is the latest. It brought in the support for the wait for data SQL syntax, which we just talked about in DB2 LUW. This is this is basically a slide that shows for running or your prototype or testing on Linux on Z. Here are some of the minimum requirements for running a cluster with DB2 and Data Gate. Need a minimum ZVM 7.1 or later. greater than or equal to 128 gig memory, and greater than 8 IFLs. Certain, depending on the amount of data volume, a certain terabyte of DASD, and high bandwidth network between the zIIP, the Db2Z that's going to be used as the source, and the OCP cluster on which Data Gate is planned to run. The last part, very early on, I mentioned that it's capable of running on cloud. So here is more information on it. It supports managed, it can install and run on managed OpenShift on AWS and Azure. Maybe this is a growing story, and we'll have more updates on it. Hopefully the next time we talk. So that concludes my presentation. I sincerely thank you all for listening and hope this was informative. I have my email and name in here in case there are questions or comments that I can help with. This is a new technology, and I would love to see how this is coming across to our community. Okay, yeah, so that's mostly what I wanted to share. I know that if there's anyone joining from Europe or other places, that I'm probably between your weekend or maybe your vacation and the close of the week. So once again, thank you all for the time.
Great job, Sowmya.
Thank you, Martin.
And I'm looking, and you did it's pretty new material, and people are here, but nobody had any questions today, which is just fine. But we have one final question. Let me take control back, and I'll put up my screen. If I hit the right key for a change.
Should I change presenter, Martin?
No, I have to do it because I am the host.
Okay, good.
So here's my presentation, and the last question we always ask our good-looking audience is, did you learn anything today? And we always like to see if people have. And responses so far show that an answer we are always happy to see, which is 100% of our audience learned something today, which is absolutely fantastic and not really unexpected, because there's a lot of great information here, and it looks really exciting. So with that, I'm going to finish off by cueing our Christmas-themed music today, which is unusual, but hope you're finding the comedy in this. Anybody who's a musician is saying, "What are those people doing?" But it kind of sets a strange mood to end the year on, having been a very strange year the last 2 years with COVID. So you can tell these people are well practiced. With that, I'll thank everybody for coming. Thanks again, Sowmya, for a great job. So then we'll end the year as this, and we'll look forward to seeing you with better music or the usual music next year in January. Everybody have a great weekend, and I'll ask Sowmya to share her slides with me so I can put them on the replay blog as well. So the best to you all. Have a great weekend. Thank you, and bye-bye.
Thank you.